Hello, my name is Martin Ettenberg, and today I'm talking about shortwave infrared technology and what we're doing here at Princeton Infrared Technologies. First of all, shortwave infrared is imaging from 750 nanometers all the way through 2.6 microns. So basically it's the range beyond what your eye sees and then up through where glass no longer transmits. So the advantage of shortwave infrared is you can use glass optics and focus with glass, which allows you to actually do imaging through glass, whether you want to do hot glass bottles or processes that are behind glass, and you can use glass optics, which is a really big advantage of shortwave infrared. So a lot of people are using shortwave infrared for multiple applications, but one of the big ones is moisture detection. So here I have a glass of water, and one of the advantages of shortwave infrared is water. The problem is it's clear, much like the glass here, and it's hard and visible to actually see the water level. But in the shortwave infrared, you can see, here I'm holding a glass of water, water is very absorbing. And different liquids actually absorb differently in different wavelength bands. So in the shortwave infrared, we're able to look at different chemistry of different liquids by looking at the spectroscopy, as well as the absorption wavelengths of those wavelengths. We're able to tell different compositions of different chemicals. And this is one of the big advantages, one of the uses of shortwave infrared is for chemical detection, as well as differentiating chemicals or differentiating different parts of your processes that you may not be able to see with your eye, but you could pick up in shortwave infrared because you're picking up different reflected signatures. Right now we have here showing is our 1280 by 1024, which is our high resolution flagship camera. It's 14-bit, 1280 by 1024 resolution at 12 micron pitch. In addition to that, it can see from 400 nanometers all the way through 1700 nanometers, and one of the big advantages is you can cover visible as well as most of the shortwave infrared spectrum. We also have now, we just introduced it to show our linear or line scan camera. Now the line scan camera allows you to do things in a machine vision type world where things are on a conveyor belt or on a processing line and they're moving past. The one-dimensional array allows you to create a two-dimensional image by passing by. Also used on UAVs or satellites where you have motion already occurring. The advantage of this is it's a much lower cost system, easy to integrate. It's got camera link as well as USB output. It's even powered by USB 3 and is USB 3 compatible. So people use this in machine vision applications as opposed to when they can create a two-dimensional image through motion. And what's one of the big advantages of using that, especially in moisture detection applications, like in paper processing, or if you're looking at thermal applications where you need to do high speed. A microbolometer is great for thermal applications for temperature measurements, but microbolometers are generally pretty slow. They're not good for fast, high-speed applications like on a processing line. Shortwave infrared, if it's hot enough, actually emits in the shortwave infrared as opposed to reflected signatures, which is most of shortwave infrared. But if it's hot, it emits, and when it emits, we can actually image it at high speeds with these line scan cameras as well as 2D cameras. And one of the advantages that we're doing at Princeton Infrared Technologies is we're a fabless company, so we actually use other fabs to build our materials, which really cuts down our overhead and allows us to manufacture different products in different ways at very efficient, high volumes at much lower cost than the competition where they have their own fabs and their own overhead involved in that. So I'm Martin Ettenberg, and it's Princeton Infrared Technologies. Please feel free to call me with any of your shortwave infrared questions. Thank you.